Hello there guys, and welcome back to another epic Inexorable maths video. In this video we're taking a look at solving quadratics using a substitution. Okay guys, that's a bit crazy. What does that mean? Well, you'll see in a second. Just want to mention we're in a different room today and it's a bit wild. I don't really know how much of this room you can even see. But luckily for us, maths is universal. So it doesn't actually matter what room we're in, the maths is going to stay the same. So it's quite chill. We'll probably be back in the normal room in no time at all. Okay, so let's get straight into the video. Let's try to solve x to the power of 6 plus 9x cubed equals minus 8. Basically what we're saying is, what number multiplies by itself like 5 times, or what number has 6 of them all timesing together, plus 9 lots of that same number cubed equals minus 8. What number is that? Or maybe numbers, maybe there's 2, right? Because it's well, there could be lots technically because it's x to the power of 6, but I'm going to tell you guys something crazy. First of all, there's 2 things that we've got to worry about, right? One, it's not equal to 0. So you might say, well, it needs to be equal to 0, we can't do it. Second of all, we don't know how to do that because we only know how to go up to x squared, because every single question we've looked at in quadratics previously has been in the form y equals ax squared plus bx plus c. We have not gone above x squared. So how on earth are we supposed to do x to the 6? Doesn't make sense. I'm going to show you something crazy. First things first, we haven't spoken about this. If you have something that's equal to a not 0 number, not a problem guys, because you can rearrange the equation. So let's just get straight into this problem. We can rewrite this and say x to the 6 plus 9x cubed. Okay, we want it to equal 0. We want it to equal 0. So let's simply go from minus 8 to 0. How do we go from minus 8 to 0? We add 8, right? So why don't we add 8 to both the left and the right side of the equation? So we're going to add 8 here, and we're going to add 8 to this side. If we add 8, that's just 0, right? So we can say it's equal to 0. So this and this are the same thing, okay? They're the same thing. X to the 6 plus 9x cubed plus 8 is 0. Same problem written differently. Now we don't need to worry about very strange occurrences when it's not 0, because you can't solve this unless it's equal to 0, so now it is perfect. What's gone wrong though? What's happening? We've still got an x to the 6, we've still got an x cubed. This is where the substitution comes in. What is a substitution? Well, actually I'll do this first. What is x to the 6? Well, there's lots and lots of ways that you can write x to the power of 6. One of them is x cubed, all in brackets, and then squared. So x cubed and then square that. That is the same thing as x to the power of 6, because from index laws we know if you have something in brackets to a power, the 2 powers here multiply together. They multiply. So it's x to the 3 times 2, which is x to the 6. Okay? So x to the 6 is the same thing as x to the 3 squared. We're going to then add 9 times x cubed. That was already there, I'm just putting brackets around it. Plus 8, that was also already there, haven't even changed it at all, and it's still equal to 0. So what's going on now? You might be looking at this and thinking, wait a second, I actually see something here. This looks a bit like a quadratic now. We've got something squared plus something plus a constant equals 0. That actually looks quite familiar. Okay, so let's come over here and let's do a substitution. We're going to say let, and we can choose any letter we want. I'm going to say u because that's normally what we would do, but you can some people do t's, some people do all sorts. I'm going to say let u equal x cubed. So I'm going to introduce a new letter into this equation, and it's going to be equal to, it's going to be the same thing as x cubed. If u is equal to x cubed, that means we can rewrite this. We can rewrite this as u, because that's an x cubed, squared, plus 9 times, well that's an x cubed, and there we go. So 9 lots of u, because u is x cubed, plus 8 equals 0. Hope this makes sense. Hope this step from here to here makes sense. We've just replaced all of the x cubeds with u's. That right there is just a cold, hard quadratic equation. There is no if, buts, and maybes. I mean, yes, given we're using u's instead of x's, but that should not be a problem. Let's just solve this. We can solve it by completing the square, we can solve it by using the quadratic formula, or we can use our typical method. I feel like we should use our typical method. So let's find two numbers that times to make 8 and add to make 9. Those numbers, the one that times is to make 8 and adds to make 9, or the two numbers that times to make 8 and adds to make 9, are going to be 8, so we're going to do u plus 8, and 1. So we're going to do u plus 1 equals 0. Because 8 times 1 is 8, and 8 plus 1 is 9, so it satisfies. So we've got u plus 8, u plus 1 equals 0, which means, guys, we should have practiced this a lot by now. U has to equal minus 8, u has to equal minus 1. Because if you put minus 8 where u is, that bracket goes to 0, which means this has to be true. If you put minus 1 where u is in this one, that bracket goes to 0, it's true as well. So these both satisfy this equation. Beautiful. U is minus 8, u is minus 1. Let's come over here. With our knowledge that u is equal to minus 8 and u is equal to minus 1, if u is equal to minus 8 and minus 1, guess what else is equal to minus 8 and minus 1? X cubed. Because u equals x cubed, that's how we've defined it. So minus 8 is equal to x cubed, and minus 1 is equal to x cubed. This also should be a fairly logical step, because we're literally saying that u is the same thing as x cubed. So if u is equal to minus 8, it makes sense that x cubed is also equal to minus 8, and the same thing with minus 1. So now we just want to look at this. If x cubed is minus 8, we're basically saying what number, 3 of them times together to make minus 8. Okay, let's think about it. Minus 2 times minus 2 is positive 4. Times positive 4 by minus 2, that's minus 8. So one of our answers is x is equal to minus 2, because minus 2 cubed is minus 8. And if minus 1 is equal to x cubed, what number has 3 of them timesing together to make minus 1? Well, that's just minus 1 again. Boom. Why? Minus 1 times minus 1 is positive 1. Positive 1 times minus 1 is minus 1. So our answers are x is equal to minus 2 and x is equal to minus 1. If you put a minus 2 or a minus 1 in this problem, it will indeed equal minus 8. Or in other words, if you put a minus 2 or a minus 1 in this problem, it will indeed equal 0. Same thing, same problem. The answers are minus 2 and minus 1. I'm going to do a second part of this video where we do another example, just so it's like fully like embedded in our minds. But this is the principle behind solving a quadratic by a substitution. In general, you can do this method if you have an x, or maybe it's a t, or any letter you want, something to the power of a number, doesn't matter what the number is, plus something else times x, or whatever your variable is, to the power of half of the first number plus a constant equals 0. Or in this example, like you can easily make it such that if you add a constant, you get 0, right? This is the same problem as this. But for example, you could do, I don't know, x to the 4 minus 2x to the 2 plus 1 equals 0. That's valid too, because this is double this. What you couldn't do it on is, let's say, I don't know, x to the 3 plus, I'm just making something up, 5x squared plus 3 equals 0. You can't do it on this because this is not double that. So there's no way that you can make a substitution where you can like get an x out and put it in the form where the original thing is being squared plus the original thing plus that constant. It's not possible to do it in this example. So this is a no, and this is a yes, okay? In general, okay? So you need to just practice to sort of get the hang of it, but as long as the power in the first one is double what's in the second one, you can do it. Anyways, guys, thank you so much for watching this epic video. Please like and subscribe if you enjoyed, and I'll see you in the next one.